Hi friends, welcome to Unit 1, Day 1 Notes. This one is over equations and inequalities. And specifically we're going to be focusing on the linear equations, formulas, and problem solving. Example 1 is solving and developing if it's conditional identity or a constant equation. This first one, this looks like it gets in pretty deep. It doesn't. There's actually something that we can do to this to make this a lot easier. I know that fractions overwhelm you. Calm down. We can get through this together. I believe in us. First thing I want to talk about is something called clearing fractions. Clearing fractions is your friend. If you want to get rid of fractions in problems, then knowing equivalent forms is going to be super helpful. One of the things that you can do to clear fractions is look for a common denominator that you can multiply through with each of the values. So here I have 3, 2, and 4. So if I take the least common multiple of 3, 2, and 4, I end up with 12. How did I get that? Well, 3 times 4, because 2 is contained within 4. 3 times 4 is 12, so I can multiply through both sides by 12. Remember, I'm multiplying the same number on both sides. This is a different idea than multiplying a number by 1, numerator and denominator. So multiplying both sides by 12, that clears the fractions. So I'm going to start off by doing that. That's going to make this problem a whole lot easier. So multiplying through by 12 on both sides. That's going to be 12 times 2x plus 4 over 3. Plus 1/2 x. X is in the numerator. Equals, again, 12 times 1/4 x minus 7/3. So when I multiply through by 12, I'm multiplying each term by 12. I'm actually not going to distribute in to each part of here. Instead, because I know that it's going to be 12 over 3, I'm going to have 12, and then keeping that 2x plus 4 in parentheses over 3, plus 12x over 2, and then here 12 over 4x minus 12 times 7. I can do that and then divide by 3. Instead, I'm just going to do 7 like this, divided by 3. Now, some of you may have been like, oh, I can skip that. I know that 12 divided by 3 here, I know that's 4. You're right, it is. And that's okay. Just know that 2x plus 4 is still in parentheses as we go through and distribute. Then I have plus 6x equals 3x minus 4 times 7, which I know is 28, but I'm going to write that on the next line. So that helped clear the fractions. Does not change the value. If you look at my denominator, I did not have any variables, and that is okay. So now simplifying this, 4 times 2x is going to give me 8x plus 16 plus 6x equals 3x minus 28. Next I have 8x and 6x is 14x plus 16. I'm simplifying, combining on both sides. Equals 3x minus 28. I'm going to subtract 3x on both sides. Gives me 11x plus 16. It's negative 28 minus 16 on both sides. 11x equals negative 44, divide by 11, divide by 11, and I get x equals negative 4. And that is okay to have. That gives me a conditional, and the condition is x equals negative 4. So this is a conditional with x equaling negative 4. Number 2, this we can simplify through by distributing. So this gives me 6x minus 12 equals 7. Don't forget to distribute the negative sign. Minus x minus 5. Simplifying, so I'm going to have, let's see, if I add x on both sides here, so that gives me 7x. And then minus 12 equals 7 minus 5 is 2. And I can, let's see, add 12 on both sides. Add 12 here, add 12 here. I get 7x equals 14. Divide by 7, and I get x equaling 2. So that is also a conditional. Now that's the next one. If I distribute the 3 to the 3x and the negative 1, I have 9x minus 3 equals 9x plus 7. Oh, uh-oh. I can already see that these different values are going to be different because 9x's cancel and I have negative 3 equaling 7. That is not true, so this is a contradiction. Contradiction. So again, if you think about, okay, what values satisfy this? What values would make x true? That's the null set. Nothing. There's no values of x that would make that true. And then for this last one, if I distribute through the half to both of these, again, I'm going to do that. If I distribute the half to both of these, it comes out to be nice integers, so I'm okay with that. So that gives me 4x minus 2 equals, and then if I distribute that negative 1/3 again through, I get nice integers as well. Negative, negative, so that's going to be 4x, and then minus 2. I have the exact same thing on both sides. Beautiful! This is an identity. Identity! And that's because all real values of x would make this true. A way that we write that, we would say x is an element of the real numbers, because that would make it all true. Join me in the next video as we go over example 2.